Hello Algebra students, and welcome to our first video lesson. This lesson is going to be on Unit 1 and Lesson 1. And so for our objectives, it is I can evaluate algebraic expressions. So we're going to be talking about algebraic expressions. We're going to, for today, we're going to review some of those vocab words that we had talked about earlier today. And then you have 4 examples on how to substitute algebraic expressions. Remember that for this video, so that I know you are watching, make sure to, when you submit this video, please make sure to put in the code word for the video. Sometimes I might make it a little more challenging to get your code word, but for this one, it'll be fairly simple. Just keep watching out for it and make sure to put it in your when you turn it in. Alrighty, so we're going to go ahead and start taking a look at some of your examples. As we go through, and as we go through, we'll kind of remind ourselves of some of the terminology that we needed to know. And so example 1 says to translate from algebraic symbols to words. Give 2 ways to write each algebraic expression in words. So we're going to take a look at each one, and we want to try and use this in English words and express these. So understanding and knowing what different words are used for different operations is going to be important. So one of these words, when we look at this first one, we have an addition symbol. So we could use addition, we could use sum, we could use, what else could we use? Gained, because you get larger. All those would be the ways that we could describe this. And for A, I would probably say something like the sum of x and 3. Something else I could say, maybe addition of a number. Addition of a number in 3, because remember this x is your variable. So if you aren't addition of a number x and 3, that would work too. So then let's look at B. You've got your subtraction symbol. So we've got m minus 7. So I could say m less than 7, or m 7 less. You'd have to go backwards. So 7 less than m, because if I said m less than 7, it's actually 7 minus m. So then I could say m subtract 7. That would be another way to write this one out. So as we keep going, we're going to look at all your now your multiplication and division. So I could say the product of 2 and y. Because product means multiplication. Could say 2 multiplied by. I hope I'm spelling this right. Multiplied by y. All right, so those are 2 ways you could talk about multiplication. And then this one is division. Sometimes it's just a little harder to write this out on the computer, but k divided by 5. So the quotient of k and 5, or k divided by 5. Either those would work. So being able to understand and also rewrite them is going to be important to our understanding of how these algebraic expressions work. So let's go ahead to example 2, which is we want to translate from words to algebraic expressions. So we're doing basically the opposite of what we did in example 1. So let's go ahead and read these and see if we can write them in a mathematical way. So using your symbols for your operations or the number symbols or the letters. So it says that Ava reads 25 pages per hour. Write an expression for the number of pages she reads in H hours. So something I like to use when I've got word problems is a thing called power math. Each part of power stands for a different part of what you need to do to understand the problem. So the first part is you underline what's the actual question. And so the actual question or the directions for us is write an expression for the number of pages she reads. You could continue on with more directions, but you can use it very direct. O would be then your operation. You want to circle your operation. And the biggest part that is going to tell you the operation is this per hour. So this is how many she reads per hour. Then you want to, your words are your next part, and you want to box in any part in words or maybe numbers. So I would say H is your hours would be important, and the 25 pages is important. So she reads 25 pages per H hours. If I want to write an expression that would express that, I would have 25, and I would have H. And my operation that would be in between them is a multiplication. So you could write it like this, or you could write it as just 25H. So if I wanted to calculate how many, she read for 3 hours, how many pages did she read? I just put in a 3 for H and solve it. Let's look at B. B says that Sam is 2 years younger than Sue, who is Y years old. Write an expression for Sam's age. So again, here is my direction. We underline that. We look at my operation, and sometimes it's not as direct in here, but I would say your operation or how to figure out your operation is younger. If someone's younger, I would assume that I would want to subtract it. Okay. And then I would box in any other important information, which is my 2 years. And my Y years. So I know I went into power math about the P, the O, and the W. The E is an estimation. You may not already be able to do that just by kind of looking at this. I usually end up skipping the estimation part, just especially with us being in older grades. That is not as important on some of these steps. And then R is your real answer, so actually solving it out. So those are the steps we do when we get through it. So it says Sam is 2 years younger than Sue, who is Y years old. So to figure out how old Sam is, I would say Y minus 2. And that would be mine. Because he is younger than Sue. Sue is Y years older. I would subtract 2. Alrighty, and your last one here says that William runs a mile in 12 minutes. Write an expression for the number of miles that William runs in M minutes. So again, I'm going to write an expression. That is sorry about my timer, guys. Alexa, stop. I have an Alexa in my house. Sorry about that. So you want to write an expression. Again, your operation, I would say, is... It's kind of tricky in this one to find it. Maybe for expression for the number of miles that runs, it might be this kind of part where you can kind of figure it out. Number of miles that William runs in M minutes. So in this case, your problem is actually asking you to divide, because I want to know how many miles he runs in that many minutes. If he can do a mile in 12 minutes, this is going to show me a division. So the other part is going to be important is 12 minutes and M minutes. So what I would do is I would take my M, so how many minutes did he run, divide it by 12, and that would end up showing me how many miles he ran. You can also write it as M divided by 12. Again, there's multiple ways to represent your operations. If at any point you need to pause this video as you feel like I'm going a little too fast, that is at your discretion. I just want to really keep these videos to about 10 to 15 minutes. And so pause it at any point, write down notes at any point. That is up to you on how you space this out. Alrighty, so the next one, we got example 3, because I think we have 4 examples, if I remember correctly. Example 3 says to evaluate algebraic expressions. So for this one, we need to evaluate each expression for x equals 8, y equals 5, and z equals 4. Remember that evaluate just means to solve. Okay, in this case, we have values to substitute in. So it's not like, hey, find what x is. Well, we know x is 8. And we know what y is, we know what z is. So we're just plugging them into this equation or substituting them in for the variable. So what I get to do is I'm going to rewrite this with the values that are now for these letters. So instead of having x here, x is now 8. That's what the directions told me. Plus my operation stays the same. And my value for y is 5. Add those two together and I'd get an answer of 13. B, again, that's going to be a division, so I would rewrite this with 8. I can write it a little easier as a fraction here. It's just hard on the computer. 8 out of z, which is 4. Well, 8 divided by 4 gives me an answer of 2. So again, these ones you're just substituting in those values and finding the solution or evaluating it. All right, and one more example here. And so our last ones are always going to be more so of a realistic example, and sometimes we'll take a look at things from different subjects or different types of material and give you some real life example. So example 4 is a recycling application. It says approximately 14 20-ounce plastic drink bottles must be recycled to produce 1 square foot of carpet. So if you're into recyclable material, you can take these plastic bottles and end up turning it into a little carpet square. So A says to write an expression for the number of bottles needed to make C square feet of carpet. Well, here's my directions. Again, here's my word problems, write an expression, okay? I would say that it's going to be important to know that you have C as your square feet of carpet. It's going to be important to know that it takes 20 plastic bottles, or sorry, yeah, 20. I think this is supposed to be 1 ounce. Sorry, 14 20-ounce. I'm reading it wrong. Okay, so it takes 14 20-ounce bottles to make 1 square foot. So to figure this out, to write an expression for the number of bottles needed to make square feet of carpet, I don't know how much C is, but it takes us 14 bottles for each square of carpet. So then I would put a 14 times C or 14C. That way we can use that to be like, oh, okay, so how many square feet of carpet do I need? That's how many bottles then I'm going to need. So here's basically that problem right down here. So find the number of bottles needed to make 40 square feet of carpet, 120 and 224. So what I'm going to do is I'm plugging this in for C. So it's like, okay, I need to evaluate C for 40, C for 120, C for 224. So I'd have 14 in this case. I like to always put parentheses when I've got a multiplication like this. So I'd want to do 14 times 40, 14 times 120, and 14 times 224. So I believe I can do the first one in my head fairly well. Okay, so 14 times 4. I just want to make sure though. Feel free to grab a calculator for this one. It's a little harder, you could write it out. I thought I got it right. So that would take, if you wanted 40 square feet of carpet, it's going to take you 560 bottles. How about if I wanted 120? All right, 1,680. Hey, I didn't forget about your code word. Your code word for this lesson is math is cool. Just put math is cool in it. All right, and 14 times 224. Oh my goodness, 3,136 bottles. So that's how much it's going to take you. And here's kind of your real life example where, you know, people might need to do math if they're buying recyclable carpet. So let me know if you've got any questions. Feel free to always go back through this video if I was going a little too fast. When we meet tomorrow, we will be working on the assignment together as a class and going through these problems. So it'd be also a really great chance to ask any questions that you might have about what we were doing. See you guys tomorrow. Bye.